Hi, I'm Rich with insideHPC. We're here at the Intel HPC Developer Conference in Salt Lake City, and I'm here with Mark O'Connor from Allinea. How you doing today, sir?
Hey, great to see you, Rich. I'm doing great.
It's been a while, and I noticed our photo was together on a Twitter thing. They're using it for marketing, which we'll get the royalty check later.
I'm sure we will.
Yeah, we will. But I wanted to ask you, you had a talk here at this conference. Can you tell us what it was about?
Yes, the title was Scaling Deep Learning. So what I did is I took a reinforcement learning approach for running deep learning on like Atari games, learning from pixels, and I scaled this to 1,500 cores. I took a very, very simple model, and it turned out this model, though it was extremely simple, it scaled very, very well. And I cut down the time compared to DeepMind's A3C approach, which takes 2 hours to beat Atari Pong, in just 3.9 minutes. So that's faster than a human can play a single game.
Wow, that's significant speed up. Were you able to use any Intel technologies to make that go fast? Or?
Yeah, sure. So the Intel MKL library, I'm always a big believer in using the vendors' math libraries where they exist, and MKL is a great example of that.
Yeah. Okay. So, in general, I haven't really thought about you guys as a deep learning developer tool kind of folks, but I would be wrong there, wouldn't I?
Yeah. You see, the thing about deep learning is it's coming to HPC whether we want to or not. It's the hyperscalers like Google are already running their models on 500 plus nodes just for a single run. And the reason they're doing that is so their researchers get their results faster so they can make better progress. This is the critical way to push the industry forwards. And if open science wants to keep up, where are they going to turn to those kind of resources? They've got to use HPC. So it's really our duty to help these people have access to the tools they need and the systems they need to keep science open and stop the big companies dominating us.
Yeah, you've got all these open source frameworks springing up, right? And no one's ever seen them before because they didn't exist a month ago. So it sounds like a pretty dynamic space.
Yeah, that's right.
Yeah.
And oftentimes the part of the framework that does the real high performance scaling remains internal to the hyperscaling company that produced it. That's their secret sauce, and they put some kind of open source plugin that doesn't perform as well. So you've got to be really careful.
So, I wanted to step back to that optimization problem you were talking about, because, you work on these codes and, with the, hundreds of thousands of processors sometimes trying to get that to scale. In this particular problem, were you using the same Allinea tools?
Yeah, we used the same tools, linear map, linear performance reports, and in fact EDT too.
And what did that performance report look like? Did it look like, oh, I know what's going on here? Or what
well, yeah, that was when I was doing a different run trying to scale on EC2 with GPUs.
Yeah.
And it wasn't scaling really very well. And I thought maybe it's the networking or maybe it's the GPU. And I did a performance report, and it showed actually it wasn't using the GPU just 10% of the time.
Yeah.
The networking was only 10 megs a second. What was really holding back was unnecessary memory copies between the CPU and the GPU all the time, because the code was doing some crazy stuff in validation.
Okay. And what's been your experience with the new Intel Xeon Phi, right, that multi-core? Does that need a lot of code changing to get it to perform?
So I found you have to pick your applications.
Yeah.
One of the applications I tried, I got well over 2x speed up on Xeon Phi. Another one, particularly in reinforcement learning, where you have a simulated model that's running. Yeah. That's not something that performs very well in the Phi processor. So you've really got to understand the kind of the instruction mix that's going into your application. Something you can see with performance reports will let you know whether to run it on a Xeon Phi, or even some kind of other architecture.
Okay. Well, you guys will be exhibiting this week here at SC16, right? What will you be showing off?
We'll be showing off the new release, 7.1.
Okay.
We'll be showing off a whole bunch of interesting things around deep learning, around best practices for regression testing. It's going to be great.